Can be measured, range of the method as prescribed in the BIS is 20 to 740 microgram per cubic meter, or 0.101 to 0.4 ppm. Here one would like to know how to convert the ppm into microgram per cubic meter or milligram per cubic meter. That you suppose you have got 1 ppm, that can be multiplied by 22.4 or 22,400 divided by molecular weight of the gas. That will give you the microgram per cubic meter of air. The absorbing solution required is 4 gram NaOH, 1 gram sodium arsenite in 1000 ml distilled water. Sulfanilamide, you have to dissolve 20 grams in 700 ml distilled water. It is not mandatory to prepare these standards. You check out how many samples you are going to monitor in a month or 2 months or 3 months, because certain chemicals have got a shelf life. Certain chemical has to be kept in the refrigerator for 15 days or 2 months or 3 months. So you prepare those quantity of standards, do not waste chemicals. You try to ascertain how many samples you are going to monitor, plus how many samples are required, amount is chemical required for calibration purposes. You reduce this amount proportionately. Suppose this is, here you are making 700 ml sample, you need for, suppose 1000 is here using, you want to make 100 ml, you reduce that quantity 10 times. Then you dissolve 0.4 gram NaOH in 100 ml. Likewise 20, here you reduce it by 2 in 70 ml. The same chemicals can be prepared in proportion of what the chemicals, how many chemicals, volume of the chemicals you require. Again you have to collect sample in the gaseous attachment. A 10 ml of absorbing solution NaOH is taken into a test tube, impinger, this is the method of analysis. Now sometimes you have taken initially 10 ml, 20 ml, 25 ml, 50 ml absorbing solution. During time of collection of sample, depending on temperature of the day, there will be some evaporation loss of the solution. How to dilute, make up that loss? Can anybody tell me? Suppose we have taken 10 ml, after sampling only 9 ml was left. So how to make up 10 ml? No, that is wrong. Disorder. If you add absorbing solution, it will change the matrix. Because now the total amount, 10 you have taken already, 1 ml you have added, now there will be 11 ml, it will be equivalent to 10 ml. So always make up the water, evaporation loss with pure distilled water. Please make a note of it. Then add H2O2, 1 ml, 10 ml sulfanilamide solution and 1.4 ml NEDA solution. Thoroughly mix. After each addition, wait for 10 minutes and take a reading at 540 nanometer. And read. Similarly, you have to prepare a calibration graph for this. Next. For calibration, the amount of potassium sodium nitrite can be used. You put the sodium nitrite into a oven for dryness and take 1.5 grams by uske assay value. What is the 99%, 97%, 98%? That amount is to be dissolved into 1 liter. And the results are given here. NO2 in microgram present in the 25 ml solution per ml or 25 ml. If you have prepared a graph with 25 ml value, then you have to take 25 ml. If you have prepared the graph as per ml, then you have to put the same value, then multiplied by ml of the absorbing solution. Then this has to be multiplied by the efficiency factor. The volume is in cubic meter. Next. This is the chemiluminescence method. Emission of the light from electricity excited species due to a chemical reaction. NO reacts with the oxygen and gives the excited state of NO2. And when NO2 reverts, it gives in the process light energy produced is directly proportional to NO concentration. NO is associated with NO2, therefore it is necessary to convert NO2 to NO. Next. This is the chemiluminescence. Sample layer is drawn through a reaction cell via 2 separate alternating channels, the NO and NOx. The NOx channel travels through the delay coil, enabling the same sample to air to be sampled by NO, NO2 and NOx. The NOx channel passes through an NO2 to NO converter. NO2 is converted to NO. Sample air NO, NOx channel enters the measurement cell where NO reacts with ozone in the following reaction. NO reacts with the ozone and gives NO2. NO2, the equation of one chemical reaction. Next. This. Now come to ammonia. Ammonia can be used analyzed by chemiluminescence method, by online analyzers, or endophenol method. Ammonia in the atmosphere is collected by bubbling the measured amount of the air through dilute solution of sulfuric acid to form ammonium sulfate. The ammonium sulfate formed in the sample is analyzed colorimetrically to reaction with phenol, alkaline sodium hypochlorite to produce endophenols, a blue dye. Nitroprusside accelerates the reaction as a catalyst. It doesn't take part into reaction, but it is a catalyst. Next. The range of the method is 200 to 700 microgram per cubic meter air. The limit of detection analysis is 0.02 microgram per ml. The sensitive method. Next. The following chemicals are needed: ammonia-free distilled water. If you can prepare fresh distilled water, that will be fine enough. If you leave the old distilled water, it may absorb the ammonia present in the atmosphere. So always use fresh distilled water. Then absorbing solution is 2.3 ml concentrated H2SO4, that is 18 molar. 18 molar or 36 m is the same thing. You dilute 1.8 ml concentrated, 2.3 concentrated H2SO4 to 1 liter. Sodium nitroprusside is 2 grams in 100 ml distilled water. Sodium hydroxide is 6.75. Next. When you are preparing this, those chemicals are to be exactly monitored. Other chemicals, supporting chemicals, need not to be quantitatively, does not play a quantitative role. They should be present in sufficient quantity throughout the analysis. And whenever you change the chemical process or you make the instrument repair, you should again prepare a calibration graph, a standard graph, or ideally always run the standard with the samples. There is a cross check. The buffer is to be prepared for sodium phosphate and NaOH. Working hypochlorite solution is 30 ml in 1.1 sodium hypochlorite plus 30 ml 6.75 NaOH in 100 ml distilled water. Working phenol is 20 ml of 45% phenol in 1 ml or 2% sodium nitroprusside and dilute to 100 ml. Prepare fresh every day, every 4 hours. Ammonia, dissolve 3.18 grams of ammonium chloride in double distilled water. It is stable for 2 months when preserved with after preparing this standard, you put about 5 ml chloroform as a preservative. Next. The air is known quantity of air is passed through this impanger. A sample is collected with 0.5 to 2 liters per minute. If they increase the flow rate, there may be spurting and bubbling, and the evaporation loss will be higher, and sometimes the gas may not be trapped. It is ideal to sample the lower rate. A 2 ml of buffer is added. Transfer the sample to 25 ml glass stopper flask. You can use this either conical flask with the stoppers or use a volumetric flask, because you have to make up the 25 ml. In conical flask, it will be difficult to make up 25 ml quantitatively. So it is better to use a volumetric flask. Add 5 ml of the working phenol solution, mix, and then add 2.5 ml working hypochlorite solution with rapid mixing. Dilute to 25 ml. Dilute means make up to the mark. And keep it in dark for 30 minutes. Measure the developed blue color at 630 nanometer. Next. For calibration purpose, pipette 0.5, 1 or 1.5 microgram ml of working standard solution, 25 ml flask, and make 10 ml of the absorbing solution and then proceed as in the sample. These 0.5 ml will correspond to 5, 1 will correspond to 10, and 1.5 will be corresponding to 15 microgram ammonia per 25 ml. So you prepare a calibration graph. Here is the volume absorbance, here is the volume. So when concentration, when you take the sample, you may come up with the X absorbance. You find out where is the X absorbance, you draw a perpendicular and see what is the concentration here. Next. The calculation is the same as for the weight of the ammonia present in the sample divided by volume in cubic meter. Next. Next. This is the chemical method. Air containing ozone is drawn through a medical impeller containing 10 ml of potassium iodide in a neutral solution. Neutral buffer is added to make the solution neutral. The iodine in liberator in the absorbing reagent is determined spectrophotographically at 352 nanometers. You may need a UV photometer for this. UV visible. Next. This is the reaction for the range of sensitivity is 0.01 ppm to about 10 ppm. The sensitivity method depends on the volume of air sample. If you want to increase the sensitivity, you draw the larger volume of air. There was a question about the industrial environment, occupational environment versus ambient air quality. Here in ambient air quality, we draw a larger volume because the concentration is low. In ambient air, industrial environment, the concentration high, we use the low volume samplers. So if you increase the sampling volume, you can increase the sensitivity or the detection limits. Next. The precision is 5% plus minus deviation. Chemicals required are potassium dihydrogen phosphate, bisodium hydrogen phosphate, potassium iodide and sodium hydroxide. These are method of preparation is given here. 14 gram of potassium, 14 gram potassium dihydrogen phosphate and 14.2 gram of disodium hydrogen phosphate and 10 gram potassium iodide successively are diluted to 1 liter with distilled water, aged at room temperature for at least 1 day before use. You prepare the solution and keep it 24 hours and then use it. Measure the pH and adjust at 6.8 with sodium hydroxide to make it neutral. The absorbing solution should not be exposed to sunlight. This is a precaution. Either you use the amber color glasswares, or if it is not available, you cover the volumetric glassware with a carbon or brown paper. Next. 16 gram potassium iodide and 3.173 grams of iodine successively and dilute the mixture with distilled water to exactly 500 ml to make 0.05 normal solution. Age at room temperature for 1 day before use. This is a standard solution. Next. Pipette 10 ml of the absorbing solution in bubbler. Sample at the preset flow rate. It may depend from 0.5 to 3 liters. The flow rate and time sampling should be adjusted to obtain a sufficient large concentration. Approximately 2 microgram of ozone may be obtained in the absorbing solution at an atmospheric concentration of 0.01 ppm. So we can monitor to this level, 0.01 ppm. Next. This is a method of calibration, 0.00259 iodine solution by pipetting exactly 5 ml of the earlier prepared solution, 0.05 in sample is diluted here to have a 0.0025 N iodine solution. Normally should be checked before use. Into a 100 ml volumetric flask and dilute to the mark with absorbing solution. Prepare 4 or more standard solutions in 25 ml volumetric flask by pipetting 0.1 to 1 ml. Ideally, the calibration graph is to be prepared within the expected range of the chemical pollutants produced. Immediately after preparation of the series, read the absorbance of 352 nanometer. The solution should be cover 0.1 to 1 ppm. Next. If this I already told you, significant loss of evaporation, double distilled water is to be used for makeup. Subtract the absorbance of the blank from the absorbance of the standards. When you use the blank, the reading will be higher. because there is no iodine liberated. When you read the reading, there will be there is a reduce in the absorbance. You subtract that reading from the line of the best fit corresponding to absorbance, exactly one shall be determined. To obtain a value m representing microliter of the ozone required for 10 ml of the absorbing solution to produce an absorbance of 1, multiply this normality by the factor 1.224 into 10 to the power 3. Next. For 1 centimeter cell, m should be approximately 9.6. Result of air sample may be computed from equation as AMV. AM is the corrected absorbance and V is the volume of air sampled in cubic meter. This is the UV absorption method. Next. This is a flow diagram. Yes, sample goes here. There is a particulate filter paper. Here is a UV source for tube, and this is the exhaust. Here is absorption cell, and this, the concentration is converted into through detector into the ozone. Next. Benzene can be collected on a charcoal filter. Next. A known volume of air is drawn through a charcoal tube to trap the organic vapors present. The charcoal in the tube is transferred to a small graduated tube and dissolved with the carbon disulfide. There are two methods. The charcoal is trapped in the benzene is trapped in the charcoal. This can be dissolved by two methods, by solution or by thermal desorption. For the thermal dissolver is not available at most of the places. So what we do, we dissolve it with the carbon disulfide. Carbon disulfide is a hazardous chemical. So it should be, enough care is to be taken just to avoid the inhalation of the fumes. The work should be done in the fume hood. After desorption, a liquid of the dissolved sample is injected into the gas chromatograph. The area resulting in the peak is determined and compared with the obtained from the injection of the standards. Next. There are some interferences are there. If the moisture is there, the moisture has got more of the organism will not be absorbed properly. So what we prepare is a small silica gel tube just to remove the water molecules before the organics are trapped into the absorption tube should have two or more. These are if the compound is known to have the same retention time, that will be interference, but this interference can be removed by changing the chromatographic conditions. Next. This is small sampling advantages are there. The sampling device is small, portable and involves no liquid. The tubes are analyzed by means of a quick instrumental method. The method can also be used for simultaneous analysis of number of solvents present. Next. छोड़ दे रहे हैं ये छोड़ आगे चलो एक मिनट Here I told you earlier how to convert this ppm to microgram to ppm. Here you can also use the temperature factor. Certain times the results are to be reported at NTP. Next. Now the filter paper was used to collect the PM10 samples. The same filter paper EPM 2000 can be divided into a fraction. Suppose if you cut the circles of the known area, known number of circles are to be cut, say 25 ml, 37 ml, 40 ml. The area is to be calculated from that area, filter paper, and the analysis results to be equated to 100% filter paper. If you use the filter paper, the area in which the dust collection, there will be a spotted line. The clear cut outline will be there on the dust filter paper. Certain paper will be left blank, which is pressed by the rubber cushion.